So I welcome all of you to this webinar on energy decarbonization. Now, every sector is making their input to the decarbonization journey in all the jurisdictions. And here we are talking today specific cases of commercial HV customers and rural customers, how their decarbonization journey can be more efficient. Next. Let me introduce the team. My name is Yogendra Vasisht. And today I'm joined by three colleagues from UK. It is very early morning for them. Dr. David Mills, Head of Net Zero Transition, Louis Guthrie, Senior Consultant, and Thomas Stone, a consultant. Next, please. Now, you will notice that there is a Q&A tab. So please type all your questions in the Q&A tab. We will be answering maximum questions after the presentation. And if there some questions remain unanswered, we will be answering those through email. So please do type all your questions in the Q&A tab. As you notice, this webinar is being recorded and the recording will be provided to all the participants. Next one, please. Now let me give you the Australian perspective. Similar to all other jurisdictions, Australian governments like local, state and federal, they all have set 2050 as the target for net zero. They specifically, the federal government policy is 43% reduction by 2030 and 82% of electricity supplied from renewable sources by 2030. This is in comparison to that 40% of the electricity was supplied from renewable sources in 2023. So that has to go from 40 to 82% in 7 years. The next one, please. Very recently, Minister Woven and Minister Watt announced a special package of $63.8 million for driving emission reduction in the agriculture and land sectors in Australia. So this sector is also being addressed so that they can contribute towards the net zero transition. Next one. Now, as the businesses and the household, they switch from fuel and gas, it is expected that electrification, the demand for electricity will grow. So AEMO is predicting that just for the name, the capacity required for generation will actually triple from today's level in 2050. Of course, this will be large solar, rooftop solar, onshore wind, offshore wind, but there is some component, as you can see in the purple, which is the coordinated DER or CR and storage. So this is part of the plan to make the transition more efficient. Next one, please. Now, if we consider only the business and industry, even their generation demand or like demand will require the generation that will double. So from today's 145 terawatt hours to almost 345 terawatt hours in 2050. So basically what we are saying is that every sector is switching from fuel and gas and will actually require the capacity of generation. The question is how best that requirement is met, which is optimum, which is efficient, and which is in the long-term interest of all the customers. The next one, please. I'm now handing over to my colleagues from UK to continue.
Hello, good evening, good morning. I'm Louise Guthrie. I'm a senior consultant within the Net Zero Transition team within EA Technology in the UK. And we've been previously working on a project to do with decarbonising rural networks and specifically looking at the effect of decarbonising or the pathways available to decarbonise rural industries like farms. Historically, agricultural industries have had minimal impact on the electrical networks within the UK, whether by design or necessity. Rural networks are typified by poorer power quality and greater unreliability compared to their urban counterparts because they're meshed and they're longer, stringier networks. When these agricultural industries choose to electrify, and how they choose to electrify, and if they choose to electrify, raises issues for the DNSPs within the UK for network capacity and reliability, as reinforcement and upgrade plans require development time. Vectors of change include energy demands of developing technologies in the farming industry, practical requirements for connections of new demands and generation in rural areas, and the rate of uptake of those new technologies, and also what those new technologies are. Compared to other sectors and other sort of heavier industry, agriculture is quite unique in that is likely to see increased reliance on the electrical network, while farms are in comparatively weaker areas of the network. We can't move where the farms are yet, anyway. There's a few sort of underlying reasons for why this project took place. It's more important to understand what you don't know when it comes to future energy sources, energy demands. And while we know a lot about the energy networks within EA technology, a large part of this project was understanding the evolving rural customer needs that required a bit of research and a lot of groundwork before we could start the project, like the modelling capacity that we did. DNSPs are developing stronger stakeholder engagement for their rural customers, as it is an area of a large amount of uncertainty on their networks. So just a bit of a background, sort of a farming for electricity networks, from an electricity network perspective to start with. Here's some examples of the general types of farms that exist, their current energy uses, or where they get their energy from, and why they use that energy. And then the key part in this project is if they choose to decarbonise their present energy sources, how will they choose to do that? Within the UK, for a bit of context, it's the internal combustion engine ban is looking out to 2030 to 2035, depending on the government government policy. How that will impact sort of industrial uses of diesel and the costs and prices of that is a bit uncertain. It's not something we could find a coherent and specific response to. What is important to note is that different farms have different energy load profiles. Often the dairy and the pig farms have the highest loads, which spike throughout the day, which is a key thing to consider. However, it's the energy load that's decoupled from the electricity network that is the top concern for the future networks. A significant amount of diesel and LPG is used to fuel farm machinery and heat animal housing. So is the plan to have all these electrified? That's a big if and a big hypothetical for this project. And the challenges associated with creating an electric tractor and combine harvester go beyond finding a battery big enough, because it makes them very heavy. So it's there's lots and lots of big hypothetical questions that are looking at the future of rural electricity demand. Fortunately, since there's no clear point of view or no answer, the UK DNSPs were preferring to err on the side of caution when considering this for the future, as it is there's not enough information from the electrical network's point of view to be able to make a solid future pathway. So just finishing off the challenge context in the UK, we've got the past sort of network, how the network was ran, and previously improving network urban performance provided more bang for your buck in terms of hitting regulatory targets. Rural communities already often have backups or on-site generation, generally diesel or oil-filled generators. Geographically, the terrain does not help. There's long strung-out network sections that are typical in these areas. And then the poor path performance leads to a greater need to catch up to prepare for the future. Often the farms are connected to the network through smaller, like 15 to 25 kVA transformers if it's a dedicated connection. So we've already got like a lot of individual challenges. And then you're now adding a new layer of possibility of what happens when we want to increase that electrical demand. So new LCT installations are hampered by poor network connections. There's a lack of clarity in the planning process for customers looking to connect, and it's expensive for farmers, especially those who are not landowners. There's that level of who will actually do the sort of installation and the paying for it. There's increasing pressure to decarbonise the industry. Obviously, you can't decarbonise the animals, so a lot of the marginal gains will be made in these like CO2, the fuel, the fuel burning that they have on their sites and properties. Also, something which through the stakeholder engagement EA Technology undertook, one of the key factors alongside wanting to do something good for the environment, often the rural customers are pushing for self-sufficiency above all else. They want to future-proof themselves, and they want to make themselves as self-sufficient as possible, especially when it comes to their energy demands. Rising energy costs was a real major point that they all brought up to us. So insulating themselves from that and possible volatility in energy prices is something that the farmers felt very strongly about. So EA Technology's objective for the project was to clarify the scope of challenges facing the rural networks and to provide a direction to the client to understand what immediate next steps can be taken and how they can provide thought leadership throughout the other networks within the UK. So as previously discussed, the first step was to understand those existing challenges on the rural networks and gain some insight into what rural customers perceived as their biggest barriers. EA Technology worked with and subcontracted the University of Leeds to provide expertise on the present and future business models for agricultural businesses, leading on their expert insight from their Global Food and Environment Institute. This enabled EA Technology to have an idea of what should be modelled when we modelled the rural networks to simulate the impact of the future technologies and their subsequent additional energy demand. However, the most important piece of work I think that came out of this general project was the assumptions of future technologies that may be available to agricultural businesses and the understanding that there's a low level of knowledge in terms of the future pathways for these industries. So in terms of providing concrete next steps for how do we have to approach this large challenge of rural electrification, the key outputs from this project were as follows. So when it comes to forecasting future network energy demand, the key assumption is how the existing fuel sources will be replaced. For heavy machinery, electrification is often not the answer, especially with farms and agricultural plant. There's a limit to how heavy those vehicles can be. Often the vehicles are used for a very short amount of time over the year, but for large intense time periods. So for example, 24/7 for 2 weeks, and then they aren't used for the rest of the year. That's not very conducive to changing that to an electric vehicle. So, but what happens if they don't choose to electrify those vehicles and instead choose to replace that machinery with new types of technologies like drones or robots? How we farm, it might change drastically between now and 2050. And that's something which is of key interest to any DNSPs that are looking to sort of understand their future network energy demands that are required in those rural areas. Hydrogen might be a viable option, but one thing which is key, because farming stakeholders often spoke during the project to preferring the idea of local circular economies. However, how do you develop a hydrogen local economy in some of these rural areas? And who will be doing the development of that hydrogen economy? And that similar question pops up with biofuels as well. It's a preferable option for many farmers as it allows them to continue using the same practices and methods that they already use. But it sort of there's a bit of a what if about how do we stimulate that economy for those farmers and who generates the hydrogen or biofuels. But then as part of this, rural businesses wanted to generate energy. from an electrical point of view, but it could also end up being hydrogen if it's feasible and possible for them. But a major source of uncertainty for the integration of embedded generation in rural networks is the storage solutions. The network modelling highlighted that as solar generation is assumed to be the main form of LV generation, in a UK context, this creates large seasonal swings between demands. I understand this is a lesser problem in an Australian context, but ensuring storage is beneficial to the network is important in all territories. You want to make sure that the storage is available at the time of greatest need, because if it's not, then other solutions are required. Also within a UK context, wind at an LV level, an LV connection is very minimal. That might change within the next few years as it's now been made easier. The barriers have been removed. However, from many farmers, even considering that, the solar panels were a much preferred option when you're talking about generating energy. And I imagine that it's very similar within the Australian context. The types of storage considered on this project were batteries of various material constructions, hydrogen and biofuels. I would say that each has a place in agricultural decarbonisation efforts, but for daily demand smoothing, batteries are very, very easy and attainable and are preferable for most customers. However, within the UK, the operationally critical seasonal demand shifting, that's less true. And then also, again, generation and storage feeds into this very unique rural network topology that is a problem for the DNSPs. It's difficult to adapt quickly and cost effectively if you are, for example, one of the networks that we modelled was over 20 kilometres long. The HV network that we modelled was it ran between sort of two towns. It is difficult to adapt that in any meaningful way without having to augment the whole network, the whole line to upgrade it. Supporting novel solutions at a customer connection point of view could, and especially enabling the addition of greater volumes of generation and storage at critical points on the DNSP's networks, could support their goal of a more reliable network. However, that requires an awful lot more forward planning and customer engagement to enable that those solutions are placed correctly and efficiently on the network, as within the UK, DNSPs are not allowed to own storage or generation that's connected to their network. So, after all those key learnings have been pulled out, and I'm an expert on the issues facing farmers in the UK, not yet. What's next? So it's important that the work started within this project continues. It's only the first step in an industry-wide effort to ensure that rural customers in all parts of the country can continue to have functioning farms as the new net zero legislation is written. I'd say there's a few key steps. First, greater collaboration is required between industry and subject matter experts, as across multiple sectors, the experts need to be aware of the challenges that exist in other sectors. A solution that is unfeasible for a customer isn't really a solution at all. And a solution that is unfeasible from a farming, a solution that is positive from a farming perspective, from an agricultural customer perspective, that's not feasible for a network is not a solution at all. To reach that stage, to get that level of collaboration, demonstrator projects is the key next step, the recommendation there. They need to have experts from multiple sectors, and the solutions must have input from, well, I would suggest electricity networks, agricultural bodies, gas networks if required, to ensure that these future technologies that are being implemented are suitable for use within the wider context, not just an individual industry. And as part of this, I would say DNSPs do need to be making sure they're providing correct information for these projects. This is something that's very key, and it will enable them to develop their future network plans. And also more details should be shared with their stakeholders automatically. to gather a wide range of viewpoints. Rural networks are often under-monitored. There's minimal actual information on energy use and voltage quality issues on long feeders. So without new information, network planning has one more assumption involved. And as I've already spoken about, we're assuming a lot about possible future electrical energy demand on the network in rural areas. So where the networks can find solid information, they should. Solutions are implemented must have some longevity behind them. The touch the network once approach is becoming a more common consideration in future planning. And one type of sort of demonstrator project which of interest in a UK context is the use of community generation and then taken to an extreme microgrids. There's lots to do when considering the future of a rural network, and EA Technology is working to continue the work started on rural electrification to bring that knowledge to new projects. It's a currently developing process, so very excited to see where this starts to go in the next few years. And I'll now pass you on to Tom, who's going to discuss a project he's worked on. I'll take it away.
Thanks, Louise, and let me extend my own hello to everyone. Tom Stone from EA Technology, consultant within the Net Zero Transition team here at EA Technology UK. Today I will be presenting on decarbonising what we are calling complex sites, and I will touch upon the next slide what we mean by that. So thanks, Louise. Here are some examples of what we mean by complex sites. So complex sites in this context are anything connected to the HV network. And there are some examples here. So that might be hospital buildings, it might be universities, it might be prisons, various transport hubs, or large commercial properties. It isn't by no means an exhaustive list, but some examples of what we're talking about here. And this can be buildings in either the public or the private sector are covered by when I talk about complex sites in the context of this presentation. Next slide, please, Louise. So the problem statement on here was essentially looking at what the problems are facing the decarbonisation journeys of these complex sites we've just spoken about. And this slide contains a couple of quotes from stakeholders that we gathered during our stakeholder engagement in the project. So this first one here says, one of the biggest issues we face is there is a general nervousness around the decarbonisation journey. And our hospital trust, that is in the process of putting together decarbonisation plans. A lot of our trusts are starting to identify that they will require increased capacity, which will be expensive, as others have echoed the same historically. There is uncertainty around costs associated with upgrades and timing of network augmentation or network reinforcement. So we can see here immediately that complex site owners and complex site developers have this general nervousness and high degree of uncertainty in the cost, but also the timings around anything to do with their network upgrades, network augmentations, when they come to the DNSPs with effectively requests to increase their capacity requirements. Now, in the context of this project in the UK, that was primarily due to the electrification of heat in what is a winter peaking grid over here. But that general unease and kind of lack of communication between the DNSPs and complex site owners carries regardless of what the increase in demand, what is driving that increase in demand. In any situation where demand is expected to increase on the electricity grid and there is uncertainty, that is going to affect the ability of complex site owners to put together decarbonisation plans in the confidence and with confidence that they will be able to carry through with that. And that second quote there touches on that, particularly in the context of public sector. There's often kind of restricted timelines for funding, and work has to be complete within a period of time, and the money needs to be spent. And if the networks are coming back and saying, yeah, you can connect, but it's not going to be for 5 years, the funding will have expired, which prevents decarbonisation projects from being able to take place, which is clearly a source of frustration for complex site owners, complex site developers looking to decarbonise their sites. Next slide, please. So what are the specific challenges that we've seen during the project facing complex HV connected sites? As we've already touched upon, there's poor visibility of costs and timelines associated with network upgrades or network augmentation. And yeah, the lack of visibility and communication between the DNSPs and the complex site owners, making those costs and those timelines kind of in a black box, unknown at the point of putting unknown at the point when HV kind of site owners put together their decarbonisation plans for their building upgrades. Further problems include a lack of coordination between site owners and network operators. So if we can get site owners and network operators talking to one another and working together, then some of these delays and some of these costs can be reduced by ensuring the network is ready for additional demand at the point that is required. Additionally, frequently there are long grid delays when we're trying to upgrade the network or augment the network. And some of these issues are in many ways outside of the DNSP's control, such as planning issues. But in common across the UK and many other territories across the world, both government and businesses are targeting decarbonisation of public and private sites, and they often have quite challenging timelines associated with doing so. So when we put all those challenges together, it leads to a couple of things. It often leads to unexpectedly high timelines and high prices for network augmentation when additional demand is being added to the network, which because it's not accounted for typically by complex site owners, that can really prevent quite frequently decarbonisation plans from being able to be taken forward, often after a lot of work has already been put into those decarbonisation plans about how that would be done on a site specific level, which means that there is a need for a better understanding of network capacity to be made available to complex site owners, and in return, DNSPs need to be more aware as well of what is coming down the road from complex sites and from their likely decarbonisation pathways. So in this project, EA Technology's objective was exploring how HV commercial sites, HV complex sites, and their decarbonisation plans would impact network costs and the network timelines, and how we could make this information about prices and timelines for network augmentation more easily available and visible to the complex site owners, such that they could account for these costs and these kind of grid timelines during their decarbonisation planning phases. Next slide, please. So how do we go about this? So first of all, we set up a platform that allowed the site owners to tell the DNSP what their anticipated future demand would be. So that allowed the DNSP to understand the amount of additional capacity that the sites wanted to connect to the grid. And we did that in a number of ways. If the site knew that, they could kind of tell it directly, and specifically to the heat electrification problem in the UK, we could also estimate this from their gas consumption data. Once we'd done that, we developed a proof of concept kind of modeling tool to provide budget estimates and timeline estimates for necessary grid upgrades. And within that tool, in partnership with Energy Systems Catapult, who are an organisation over here specialising in how sites can decarbonise, we provided optioneering to those site owners to help them to understand how they could reduce the cost associated with their network augmentation, or the timelines associated with the implementation of their network augmentation plans. And when I say optioneering, some of the things we considered were as follows. So we could use on-site storage to peak shift to effectively move demand from somewhere where the network, some time when the network was constrained, to some other time where there was spare capacity on the network. We could consider using on-site generation, which we found to be, in the case of solar, quite ineffective in the UK because of the seasonal mismatch between peak demand and peak generation in the UK. But in other grids, we see that as having much more potential and something that should certainly be explored. Additionally, we explored energy efficiency measures. So is there anything we can do to reduce demand and therefore reduce the need for network augmentation? And where appropriate, we could offer flexible or interruptible connections to site owners to either as a temporary measure or a permanent measure to accelerate their ability to get connected and reduce the cost of doing so. Next slide, please. So the key project learnings that we identified were that knowledge sharing between complex site owners and DNSPs must be improved, that complex site owners often face unexpected late challenges to their decarbonisation plans from network augmentation costs, and that to avoid that, there needs to be a way of effectively communicating the costs and the timings associated with network increasing demand to those DNSPs earlier in their decarbonisation planning processes, such that they can account for that and ensure that the funding is there to do that, or so that they consider alternative routes, which means they can avoid some of those costs or some of those delays. And one way that this can be done is by providing software tools, self-serve software tools that make this data available autonomously to complex site owners. Next slide, please, Louise. So what's next? EA Technology have identified throughout this project that complex site decarbonisation pathways are uncertain and remain uncertain, and Therefore, there is a need for continuous and ongoing communication between DNSPs and complex site owners to understand continuously how complex site developers are thinking they will decarbonise, when they are thinking they will decarbonise, and through what energy vectors. Will it be through electricity, or will it be through some other vector which doesn't have the direct input on the electricity network? And to facilitate better planning, both for the complex site developers with their decarbonisation plans, but also for network operators and their network kind of plans to augment their network over time. That communication is critical. So we've also identified that reducing connection costs and timelines is a real incentive for site owners. If they can avoid network augmentation and reduce those costs, then in many cases they will. And that is something that should continue to be explored and should be, where appropriate, made available as an option when offering or when giving out connection offers. And finally, the optioneering should be considered as well as a way of doing this. So as touched upon on the previous slide, using either energy efficiency, on-site generation, on-site storage, or flexible connections can all be explored as potential methods for reducing those connection upgrade costs and timelines. Next slide, please. And I think with that, I'm handing back over to Yogendra.
Thanks, Tom. Those who missed my earlier introduction, I'm Yogendra here. Look, these things are familiar to us in Australia and New Zealand also. For example, if you see the Australian rural thing in Western Australia, let's say, there are a lot of standalone power systems or microgrids. There are complex HV customers, for example, airports, those who have on-site solar generation, who wants to have on-site solar generation, storage, and they also participate in the demand response or demand flexible demand. So there's a lot more complexity happening around those customers for good. So what it is looking like, and before that, I want to tell everyone, please type your questions in the Q&A tab. We will have some time after this presentation to answer your questions if you have any questions. So there is a Q&A tab. So please do type your questions if you want to ask any questions from this panel. So just continuing on my thing, that look, network planning and forecasting has been part of network management from centuries. So, but the new thing is that this function has become very complex and very challenging. And the reason it has become that is because there is distributed generation, is because there is storage, is because there is a lot of flexibility services and flexibility in load, and is because of new energy efficiency measures. So there is basically, that complexity is driving that planning function to understand. The planning function is to forecast the load and to understand precisely the future energy needs of the customers. That those energy needs, how they will be converted into the load and the profiles of the load. And that function is possible. In the current complex scenarios, it is only possible to estimate those loads, or is not possible to estimate those loads without having close collaboration with that sector, which UK people are demonstrating how they have done it. So I'm sure that these learnings are equally applicable to Australia and New Zealand. The similar things are happening, and then as we progress on the decarbonization journey, we will be making those attempts here also, and it's already happening to some extent. And then it will be good to have those learnings and then move further. Next slide, please. Now look, if you are traveling to New Zealand, Christchurch for EEA conference, we would love to have a chat with you. I'll be there, Louis will be there, and then one of our colleagues from Australia, Thomas, will be there, and another colleague from UK, Ian Cooper, will be there. So we will welcome you. We are presenting few papers. We have a stand, EA Technology stand there. And so if you happen to be there in that EEA conference in Christchurch, 10 to 12 September, we would love to have a chat with you. If you have any questions now or later, you can let us know. Even afterwards, if you want to discuss this further, if you want to know any more information on this, if you want to ask anything, what exactly has been done, how this can be translated in Australian and New Zealand context, we are very, very happy to have a talk to you, have another discussion or another webinar or another Zoom meeting with you to discuss in details. Next one, please. So look, this is where we are, and I'll hand over to Dr. David Wills, seeing that there may not be any questions in the tab. Yeah.
Thank you. Yes. So thank you, Gendra. That was a great presentation from all. I'll see it really interesting to see some of the work we've been doing on the challenges of decarbonising rural communities and understanding how that's going to impact them. It's harvest season here in the UK, and I couldn't imagine the amount of energy a farm's going to need if they want to shift burning diesel in all their tractors and combine harvesters. Is that electric? Is that hydrogen? I don't know, but it's still a lot of energy and wholesale changes. We've got a couple of questions, but if anyone else has any questions, do type them into the chat and we'll pick them up as we go. Firstly, a question for Louise. From the work that you've done on this, is there any indication of when we think some of these challenges might start to impact the rural networks, or what sort of some of the tipping points could be when they suddenly have sort of challenges in rural decarbonisation?
Yeah, I think a big one will be around that 2030, 2035 point, in terms of that's when the farmers will definitely, if they haven't thought about it before, they will start to be thinking about it very quickly and intently, depending on how that the internal combustion engine ban within the UK will really start to impact their businesses. There's minimal discussion of what we call red diesel within the UK, which is the sort of industrial diesel that is it's used in the farm machinery and things like that. I think another main one, there's less targets surrounding specific decarbonisation of the farming sector, because a large amount of the emissions come from the animals that are reared within the country. When you look at the breakdown, carbon dioxide is actually a little bit smaller than when you consider you've got, first of all, nitrogen dioxide, and you've got the methane emissions. However, from a point of view where it's going to, the other tipping point, I generally think will be when it's the costs of other LPGs and things like that. It really is customer driven, and which makes it very difficult for the networks to plan, which is why the networks do have to get ahead of it and start sort of forcing the discussion onto the table so that they can have those plans for the future. I think within the next few years, the regulatory cycle within the UK, the planning, it is definitely being brought to the forefront by many of the DNSPs. So it will become, I would say, within the next 5 years, that's where it'll really start to be a tipping point.
Thanks. So then they'll have to start planning that into their regulatory cycles. Thank you.
Yes.
And I guess this does link in somewhat with the HV complex sites piece and just understanding the connection, understanding what's going to happen, how it's going to change. And I know a question for yourself, Tom's come up next, which was, so what are some of the benefits, or have we estimated any of the benefits that it could bring to customers or DNSPs in terms of reduced efforts, reduced connection times, something around that?
Yes, we have. We have done a CBA on this. Unfortunately, I can't remember the numbers, but we found some of the highlights from that is really significant savings in terms of facilitating carbon reductions by primarily in the UK context, allowing electrification of heat and shifting that from heating demand from gas to electricity. And then in terms of benefits to the networks directly, one of the key benefits we found was by better being able to understand the demand the additional demands coming down the track, if you like, particularly if you could kind of link up a few sites from the same kind of section of network, from the same EHV feeder, for example, then you could avoid, by accurately understanding when and how those sites were likely to decarbonise, you could avoid the need for repeat network and reinforcement, or similarly, you could avoid the need for being too cautious and over-investing in the network. So savings there would be unlocked basically through facilitating the network to touch the network once without overbuilding.
So, and obviously the kind of national benefit of being able to get these connections faster, helping achieve the country's decarbonisation targets. Obviously, is a secondary benefit. Thank you. And I guess so. Something I'm just going to push back to you, Gunnar, a little bit. Some of the benefits from that we are seeing for the HV custom connections is because of those the process in the UK where customers apply for a budgetary connection offer that is typically free, and therefore there's no costs for the customers when they're applying for those connections. Is that a similar process in Australia, or is there a cost and therefore effectively already a barrier to slowing down those connection requests?
Yeah, I think in Australia, connection process is two ways. One is the preliminary inquiries, which happens, but when it goes to the detailed feasibility, which is always the case for complex customers, there is a arrangement for payments also. But I can say, there is always what we are seeing from this future energy needs is that there will be very high number of those inquiries. So even if there are some arrangements that it can be paid, or whosoever pays is that irrespective of that, this inquiries, the volume of inquiries and the complexity is going to grow because it's not a simple load. It is about that flexibility. It is about that storage. So it is actually. There are two things now for the challenges we have. One is to understand exactly what will be the net load after the generation, storage, energy efficiency, and flexibility. And the second is what after that means what the hosting capacity the network will have after having all these things by others. So it is a question of even if the planning process, and that is why I'm saying it can take a lot more time because of the volume and the complexity. And yes, there can be a payment in Australia, I believe, for the second stage feasibility thing, but it is very much complex, and that is where for the planners to actually forecast the load for next 5 years and 10 years and do the network planning is actually very, very challenging. And that is where this understanding of how to go about it with each sector and how to work in collaboration with them, because ultimately it will benefit everyone. The more we can utilize the network, the faster we can provide the response. It benefits not only to that customer, it actually benefits all the customer connected to that network in terms of improving the utilization and efficiency. So it is for the benefit of every customer that these processes are expedited, and these processes make the estimation, the network planning, forecasting becomes more and more accurate. So that is what Australia is also trying. The regulatory process and then payment can be slightly different from UK.
Thank you. And it fits perfectly with some of this work, doesn't it? The work that we've done, understanding that Louise was talking about in terms of understanding the rural sector starts to feed in, so you can then better forecast and better estimate those connections. And then once you then get to a point where the customers are connecting, you have the HV complex sites being able to process those connections quickly and get those customers connected. Let's go. I have one more question. Probably goes to both Louise and Tom. So if we go to Louise first, what are the UK DNSPs looking at now in terms of what's the next steps for taking this forward to understand rural decarbonization better?
Yep. The immediate next steps is definitely the demonstrator projects, not just within the electrical networks, but within the gas networks as well. Hydrogen is being investigated as a more sort of firm source of energy, possible replacement. However, the electrical networks also need to start doing their own sort of work with their customers to understand that how they're planning on, I suppose, evolving their operations to make it a more decarbonised on site for themselves. And if that requires an electrical connection, that's where the demonstrator projects really need to get that level of understanding within EA technology. That's what we're looking at next, is what projects we can support and deliver to ensure that information and knowledge is being actually developed, because someone's going to have to do it. So that's what we're up to next.
Okay, and then let's Tom, the same question or related question. So DNSPs, the work that you talked about is sort of proving the value of that. What's the next steps for that project?
So the next steps of the project are, well, DNSPs need to continue to better understand their complex sites, complex customers, and they're doing this for a number of ways. So one way is kind of through the traditional people-based way. They're growing teams that are actively going out from the DNSPs to their biggest customers to understand how and when, in terms of timing, the complex site customers are going to decarbonize, and how they will decarbonize, whether that will be through electrification or through some other energy vector. But with the sheer volume of demand, demand for kind of connection applications that are coming or they expect to come to their forecasting teams within kind of relatively near-term future, certainly within the next kind of 5 years, they're increasingly looking to automate some of this stuff through software offerings, through self-serve tools, and that's particularly important with the skill shortage in the UK and difficulties recruiting kind of network planners and similar kind of engineers into the DNSPs. So by developing and putting work into developing connection tools, software tools, that helps reduce some of that burden on the network planners and frees the network planners to focus on the more complicated connection requests and the connection requests that are most likely to proceed to actually being implemented.
Yeah, thank you. Yeah, so you can get everything connected faster, and that's the development of self-service tools and the data sets to support that. So thank you. Where we are coming to the end of the session, let people get finish their days, get their dinner, get their breakfast, depending on where they're sat. I'll hand back to you, Gendra. Thank you, everyone.
I just want to say thank you all, and you will get the recording of this session. And later on, you have our contact here, all four of us, so you can contact any one of us. I'm based in Melbourne, so I'm your local connection here. So definitely do keep in touch and let us know if you want to know more. Thank you very much. Thank you all.